2.5, which is solving compound inequalities. So let's take a problem. We have a number c is less than 5 and greater than or equal to -2. All right, so we can write two separate inequalities if we really like here. So we have c less than 5. We also have c greater than or equal to -2. When we have that, we can actually place that c in the middle, okay? So what we instead can do is create a compound inequality with c, right? And we still have less than 5, but on the other side, remember, if we were going to put the c on the right side, right, this could be written as -2, right, less than or equal to c, right? So we could actually transition this guy down over here, right, and create effectively a compound inequality, all written as one number sentence. It's effectively the way that we state something is in between. So we can, of course, create our number line. All I require is, again, that from 0, we're going to locate on the number line where -2 and 5 are. So -2 is over here on the left, 5 over here on the right, clearly much further, or not much further, but further from 0 than -2. Okay, so we have a here, because on the left that has a line underneath, that means it's going to be a closed dot. And on the right inequality sign here, this guy means that we're going to have an open dot. And when it's an in-between problem like that, this is actually what's called a conjunction. All right? This is what we say is an and problem, which means we shade in between. All right, next. We're going to have a example of a disjunction problem. Let's go ahead and proof that in between. There we go. Disjunction problem, which looks like this. We have a number t is less than -1 or greater than or equal to 4. Again, this says or, so this is a disjunction, okay? So we're going to write two separate inequalities. It's going to be t less than -1, of course, then we have or. So in this case, we actually write or in between, and we have greater than or equal to 4, okay? So t greater than or equal to 4. Done, okay? This, again, is written as an or problem, which means we're going to shade the outside, okay? What I mean by that, again, we're going to put our number line out. We're going to have 0. We're going to show -1 in relationship to 0 is going to be on the left. 4 is going to be on the right, right? Further from 0. And then this guy over on the left with -1 does not have a line underneath. It's not equal to, so we're going to leave an open dot, versus 4. It's going to be a closed dot, okay, because it's also equal to. And then again, we can actually follow the direction of those arrows when we have our variable on the left, as we learned in the last lesson. Same thing over here, so this guy's going to be shaded to the right. So again, as I said, this is an or problem, so it's shaded to the outside rather in between those two values. All right, new problem. We're going to solve and graph. All right, so these are our directions. This is what it's going to look like. We have -3 less than x plus 1 less than 5. So this looks like a compound inequality. It looks like it's, in other words, it's going to be a conjunction that's an and. So what we're going to anticipate in the end is that this will be shaded in between. Let's see if it works out that way. From the get-go, we're going to have to do a split. I do not like when people operate on these inequalities simultaneously, because you're going to slash off and do things to that middle, and effectively two different problems are going on at the same time. So let's write it that way. We have -3 less than x plus 1. right? And then we're going to have x plus 1 less than 5. So whatever the middle value is, right, that's what's going to be maintained with each of those inequalities, right? So it's either going to be this guy together or it's going to be this guy together, okay? And now we're going to do two separate things. You'll see why I prefer it this way and actually require it in this class. So the first one, we're going to get x by itself. We're going to subtract 1, right? So then we have negative 4 less than x. And then over on the right equation, inequality, we're going to subtract 1 for both sides, and we're going to have x less than 4, okay? Now look, I have an x here, and I have an x here, so we can kind of smash those guys back together here. And we're going to rejoin this, where x is in the middle, but on the left inequality, we have a negative 4 less, and then less than x, and then on the right, we have x less than 4. So we have now our compound inequality written here. And then when we go to put this on our number line, because we're in a graph, right, we have to put 0 on here. We're going to show our two values, negative 4 and 4, in relation to the 0. And then for both, neither of them are equal, right? So we're going to have open dots for both. And again, just like the very first example, it's compound, so we're going to shade in between. All right, next. Again, we're going to solve in graph. Two separate problems here. 2x plus 6 less than negative 2, or we're going to have 4x minus 5 greater than 3. What's great about this is we are going to anticipate, again, a disjunction because of or. So our graph in the end, we're going to anticipate is going to be shaded to the outside. Again, we're going to see if that actually happens here. What's great is when it's already separated as the disjunction, we don't have to rewrite the problem or do that split like we had to do before. So we can actually just start operating right here, right? Subtract 6 from both sides, so I have 2x less than negative 8. Okay? And then continuing on, actually I'm going to continue my work in blue here, so 2x less than negative 8. Divide by 2 on both sides, okay? And I'm going to have x less than negative 4. Now remember, I divided a negative, not by a negative, so therefore I'm not going to flip my sign, okay? So we're okay so far. And I add the 5 to both sides, so I have 4x greater than 8, divided by 4 on both sides, so I'm going to have x greater than 2. All right, so again, it's an or disjunction, so those are my solutions here, and let's actually go ahead and graph here. Okay, so again, I'm going to show 0, I'm going to show negative 4 in relation to that, and then 2 also in relation to that. 2 is going to be closer to the 0. I'm going to have an open dot in both cases, it's an open point, and then negative 4, it points to the left, so I'm going to shade to the left. Remember to include the arrow, as we've discussed previously, and then again, we're going to include the arrow and shade to the right of 2, because that's where our arrow points. And remember, that's what we anticipated because it's a disjunction, so everything looks good so far. All right. A couple more things. Let's actually interpret how we use these in our real life problems. So we're going to say the storage temperature for chocolate is between and it's going to be between 15 degrees Celsius to 20 degrees Celsius. Okay. And we are now going to write an inequality for storage temp so that's storage temperature in degrees Fahrenheit. So we got to go back to that infamous conversion that we've used before. So here we go. So we have, it's going to be between 15 and 20, and it includes those values, so 15 and 20, right? So that's how we do in between, right? And what we're missing right here is this middle little function thing, which is that conversion equation. In this case, to go from Fahrenheit to get to degrees Fahrenheit, we're going to have 5/9, right? f minus 32. Okay. In here, I'm going to have to do that split. So I'm going to have 15 less than or equal to 5 nines, right? F minus 32, again, because we're saying that 15 is in degrees Celsius, right? So that's already in that conversion equation. So and again, we are going to have, and we want our output to be in degrees Fahrenheit. And this is going to be 5 ninths less than or equal to, 5 ninths times the quantity F minus 32 less than or equal to 20. So I have two separate inequalities that I need to complete here. So let's go ahead and start operating here. I'm going to actually multiply by 9/5 here, which I prefer rather than distributing, because I think this distribution is going to get messy. And then I guess, again, these guys, the 5 and the 15 is going to factor down to 3. So 3 times 9, which is going to be 27, less than or equal to, and I'm going to have F minus 32 on its own. I'm going to do the same thing over here on the right equation. I'm going to simultaneously complete this guy, okay? So I'm going to have, again, F minus 32 less than or equal to, and then 9 times 4 is going to be 36. I'm going to have to add 32 to both sides, okay? So show my operation here. Oops. So plus 32, plus 32. It's going to cancel on the right, so on the left it's going to be 59 less than or equal to F. And on the right, again, I'm going to add 32 to both sides. And it's going to cancel, so I'm going to have F less than or equal to 68. And look, I have these guys two together with the F by itself, so this F can go in the middle. And I'm going to show 59 less than or equal to, and I'm going to have less than or equal to 68. So that's my range, okay, in degrees Fahrenheit. All right, that's all I have got for you for today. There are some other examples in the textbook that utilize these real life problems. Go ahead and take a look. Make sure that if you do encounter anything where you divide by or multiply by a negative, you are in fact taking the time to switch your sign, right? Flip your sign in this case. Okay, so that's it. Go ahead and complete your assignment on Canvas.